Hello friends, welcome back. I am Rajneesh and this session is about understanding the certification authority, how it works and how the websites work over HTTPS. Normally the websites work over HTTP. For example, if I just try to open google.com, here you can see that it's working over a plain text. You cannot see any kind of SSL information to it, and whatever traffic you are sending from your laptop to the Google will go in plain text. I'll have a separate video explaining you that, but right now you can understand that all the text, whatever you are typing, is being sent to the Google, and whatever results you are getting back are all in the plain text format. But when you are trying to open or log in into google.com, you see that there is a certificate that you have, and if you click on the certificate you will see that it's verified by Thaute Consulting Private Limited. So this says that this is the right site which I am trying to open, and it's not any fake site. For example, if you try to open make triple O, so it could be a different site, but the certificate could say the certificate doesn't belong to that site. So as of now you can see that google.com is verified by Thaute, and if you see more information it will show you from when and till when is the certificate fine. You can see the common name corresponding to it, accounts.google.com. So this specific certificate is created for accounts.google.com, and if you try to use the certificate on www.google.com, it will not work because the certificate was created specifically for accounts.google.com. Here you have the details: Google Inc., organization unit, optional, so they didn't specify. Issued by, this is the certificate authority which signed this certificate signing request from Google. It was Thaute, and here are the details for it. And the final part that you can see is when was it issued. It was issued on 21st July 2013, and it expires on 19th July 2013. So it needs to be updated before that. It needs to be re-signed before that, or it could be a new certificate that they may obtain. So here again you can see serial number, issuer, validity, not before, the same details you can see over here. Now just a small PPT. So how it actually works is that you create a key, you create a certificate signing request using this key and send it to certification authority. Certification authority signs it and sends it back to you as certificate, which is ready to be used on a web server. And whenever you are trying to use this certificate, you need to have a key that you used to generate CSR. So this is very important. Keep it safe till the time the certificate is to be used. So coming back to the lab, here is my local machine. This is my certification authority. This is again my certification authority. So this is my RHEL6 machine, and the folder that you can see is /etc/pki_tls. Under /etc/pki you have the details corresponding to PKI or public key infrastructure. This is the certification authority corresponding to Java, and TLS, transport layer security. So under TLS folder, or you can say etc/pki TLS, you have the openssl.conf. Sorry, I have to use vi because vim is not yet installed. So this is the generic openssl.conf, which is present. You can modify it. The main section we'll be concerned is about CA, the default CA, which is that CA underscore default. Here is your CA underscore default section. What is the folder corresponding to it? etc pkica. Let me confirm whether it's present on the certification authority. Yes, it is present. Under this there should be folder certs, CRL. Certs, CRL are there. Certs is the folder that you will be putting the certificates into it. The issued certificate will be kept under it. CRL means certificate revocation list. Whatever certificates are revoked will be present in it. Database index.txt. Can you see this file? Yes, you cannot see it. So let's touch it. Copy. So this will be used to keep a track of indexes, which is the I'll show you. New certificates directory. New certs, is it present? Yes, new certificates will be placed under it. cacert.pm. If you want, you can change the name. Let's make it as rcval.ca. It could be any extension, doesn't matter. Or you can just, for convenience and understanding, if you want, you can name it as ca.crt. It could be any name, doesn't matter. Serial number, the current serial number, it's not present. Let's just touch it, and we are touching all these things in /etcpki folder, etcpki ca folder. Certificate revocation list, crl.pem. Private key is placed under ca. Let's, for simplicity, it could be any name, doesn't matter. If you want, you can keep it the same. And it's not present, we'll have to create it. So let's create it at the same time. Open SSL, gen RSA minus DES3. Let's use this algorithm, and the size, let's keep it 2048 bytes, and send it to ca.key. So it is asking you for the passphrase. Passphrase for certification authority, let's keep it my ca. Open tab, default, my ca. Okay, I just typed it to keep a reminder of it. My ca is the password. My ca, it could be anything. So whenever you are trying to use this private ca.key, you need to know the password for it. And let me see the permissions. Private, this folder can be accessible only by root. That's fine. So after you have generated this key, the next is random file is fine. Certificate name options, where they are to be fetched from ca underscore default. Certificate options, they are to be fetched from ca underscore default. Okay, other thing that's important is, by default, for how many days should the generated certificates be valid? By default, it's 1 year, let's make it 10 years. You can modify it according to your convenience. For CRLs, for how many days it should be generated. Default MD, preserve, let other variables be default. Policy is important variable which says policy match should be used, and policy match is the policy that starts from here, which says country name should match. For example, I am getting a certificate signed for any company xyz.com. Certification authority will be able to sign it only in the case when the country name matches. The same when the state name matches, organization name matches. Organization unit is optional, it may be present or may not be present. Common name is supplied, doesn't need to match. And email address is optional, may or may not match. So this works good for a company. Policy anything means let it be anything. Anything for mail address, country name could be anything, and the CA will be able to sign it. RAQ is corresponding to the request that you are creating, or the CSR that you are creating. Default bits size of the default bits that an algorithm that it has to use. Default key file name will be this one, distinguished name, and here you can see the other attributes that could be used by default. Distinguished name will be fetched from this section. Country name, if you want to set it default to N, so I'll show you when creating the certificate signing request or certificate, the default country name that will provide you will be in our case now. For state also, if you want to set it default, just uncomment it and type the name of the state. Locality name default. Organization name default. It could be a name of your organization. And email address, you can set it as default if you want. So these were the main things. Just write and quit. Now, till now what we have done is we have created a private key. Now we will be creating a certificate or CSR that will be signed by certification authority, and we may use that for signing others. But if you are talking about your own organization, you may use the self-signed certificate throughout your organization. So to create it, OpenSSL is the command. Request a new what was the name of the CA? Certificate name was ca.crt, so let it be ca.crt. So let's understand this line. This says I am requesting something which is new. X509 says it should be a certificate rather than certification authority, the format it uses. So X509 means generate a certificate using the key private ca.key, and the output should go to ca.crt, and we are left with one more thing. How much should be the validity of that key? Validity of that validity of the CA certificate, let's keep it valid for around 20 years, which says 365 1 year. into 2, or let's keep it for 20 years. Pass it to binary calculator. So right now your certification authority will work for the next 20 years. Minus days. So now you see that it's prompting you to enter the passphrase for the private key because you are using this key to create a certification authority. So the password was myCA. Here it prompts you for the country name is India because in this openssl.conf we modified the country name default to N. So just press enter. State, it prompted for Rajasthan because we entered in underscore default. Locality, organization name and organization unit name, it could be anything or blank. Common name is the most important thing. So what's the name of our CA? It's ca.rcval.n. Paste. Email address. So now if we see we have ca.crt. Let me see the location. What's the location of ca.crt? It's in /etc pkica. Fine. In etc pkica I have ca.crt. So I got it signed for 20 years. If I just want to analyze the CA once again, in days minus issuer uh, OpenSSL x509 minus in minus it should be dates. No out, don't display anything extra or the complete certificate. So it says that it can be used or not before 2000 okay, not after. So its validity started on 8th November 2012 and it's valid till 2032 November 3. The number of days, it comes out to be around 20 years as I specified while creating the certification authority. So issuer is, it's the same, and if you see for whom it was, here you can see the subject. So subject and issuer are same because it's a self-signed certificate. Now we have a certification authority ready with everything, and we want a client to create a key and ask the certificate authority to get it signed. Let's go with it. uh, let's create a temporary folder, and the first thing is gen RSA type of key minus DES3 size, let's keep it 204, it is pretty secure enough, and send the output to let's say it's client.key. Now the passphrase, let's keep it client, or it can be anything, CLIENT. So now you have client.key visible to you. Now the second part that I need to do is I need to create a certificate signing request which I'll be sending to certification authority. Open SSL, request a new create a new request as a CSR. So minus key minus out is let's say www dot rcval.in. So this is our web server for which I am expecting the CSR. As I have to use client.key, I need to provide the password for the client, which is client. Now you can see the country name as Australia rather than India because I didn't modify it on my client machine. So I'm in India, in Rajasthan, in Pilani, organization name, anything, and organization unit name. Common name is the most important thing. Let me copy it. Challenge password, let's keep it as blank. Now we have a CSR which is ready to be signed by the certification authority. Let's move to the certification authority. uh Here I was. Okay. I move to TMP. VIM www.rcval.in.csr. Okay, there are two ways. Either you can SCP or you can just create the same file over there. Let's use SCP. Root at 10.0.10.2. Okay, client libraries are not there. Okay, so the other approach could be just copy the file and just paste over here because it's a simple plain text. And if you see to the file, it says begin certificate request and end certificate request. So now open SSL CA for the certification authority in out. In the out file we are just changing the CSR by CRT. So finally what it is doing is using OpenSSL command as a certification authority, and it says take file CSR file and provide the output in CRT file over here only. Now it asks you for the password corresponding to CA key. I think it was my CA. Okay, unable to load serial number. Okay, let's initiate this file. This file should have the first serial number. So now we have the serial number 1. which will say try to sign the first try to sign the CSR and provided the serial number 1 my CA. Okay, signature was fine, everything was fine, but there is a policy which says the organization name should be the same. Here the policy says policy match is to be used, and which says organization name should match. In case you are trying to sign the certificates from anything, so just change the policy to use this one. Or the other option could be you are going to create a CSR once again matching the organization name. So best approach as of now is just change the policy that it uses. So now it will be using the policy anything. Here you have typed the same command CA -n as CSR and output as CRT. Asks you for the password corresponding to key, checks, it's okay, and here it shows you the details of the certificate that will be creating. Serial number is 1. It will be valid for 10 years, 2012 to 2022. If you want, you can specify shorter duration. I'll show you. There is a variable default days that you have set to 10 years. You can set it to 1 years or any time which you prefer. Subject, and here you can see the details of the CSR that you received. In case you agree that it's a right one and you can sign it, then go ahead and sign it. So finally, this certificate is going to used by a web server. So finally it is not going to be a certification authority. This certificate that I am using cannot be used as a certificate authority. OpenSSL generated certificate and keys. So sign the certificate, yes. Commit, yes. Now you can see that you have a certificate, this.csr. Copy, and here you have the certificate. I just get it back to my client machine, CRT. This is request and CRT is the certificate, and here you can see the details about your certificate. Okay, so in TMP SSL I created the certificate file. Now let's try to browse it. TMP SSL. Now you see the identity, or it can be used on www.rcval.in. It is verified by the certification authority, the name of which is ca.rcval.in, and it expires on 2022 November 6. And here you can see the other details about the certificate. This is the detail of my certificate. These are the details of the issuer who issued it. Version, serial number is 1, and here you can see all of the details that you want to see. Regarding the use of the certificate, I'll be configuring Apache in the next session, and I'll show you. So before we finish up with it, let's recall the things once again. Here is the PPT. I created a key, created a certificate signing request, send it to the certification authority. Certification authority signed it, verified it, and sends me back the certificate. Now CSR is of no use to me. I can use my key and certificate to implement or to use this certificate. And regarding the use, it will be a different session. Hope you understood this session. Thanks for listening. Have a good day.